In this video, we'll look at quotient rules for exponents and the zero exponent rule. The quotient rule says that when dividing exponential expressions with the same non-zero base, so notice that the base cannot equal to 0, subtract the exponent in the denominator from the exponent in the numerator. Use this difference as the exponent of the common base. So if I had b to the mth power over b to the n power, that would equal b to the m minus n, and the base cannot be 0. So for example, let's say I had 2 squared over 2 to the 5th power. So using this rule, I would rewrite that as 2 to the 2 minus 5, which would give me 2 to the negative 3. It's okay if you get a negative, but then I want to use the rule from the previous video, the previous lesson, where I rewrite the negative exponent by moving the base 2 down to the denominator and changing the sign on the exponent. So this would be the same as 1 over 2 cubed. And 2 cubed is 8, so that would equal 1/8. Now, if you have numbers, you can check this in your calculator. And let me pull the calculator over to the side so I can see what to type in here. Okay, so I could put in 2 to the 2nd power, use my right arrow to get out of the exponent, do divided by, and then 2 to the 5th power. And if you want to change your result to a fraction, use this convert to fraction button right next to the answer, and it will convert it to a fraction. So we know that 1/8 was correct. With numbers, you can always check in the calculator. If you have variables, you'll have to know these exponent rules in order to simplify your expression. The next rule is quotients to powers. When a quotient is raised to a power, raise the numerator to the power and divide by the denominator raised to the power. So in other words, if I had a over b all raised to the nth power, that would equal a to the n over b to the n. And the base b cannot be 0 because I can't divide by 0. All right, so let's look at an example. Let's say I had x over 3 in parentheses, and that whole fraction was raised to the 2nd power. That would equal x to the 2nd power, or x squared, over 3 to the 2nd power, which would give me x squared over 9. Now this can get more complicated because we learned some other exponent rules in previous lessons. So what if I had something like 2x to the 4th divided by, let's say, divided by 3. And that whole expression is raised to the 5th power. So using the rule we just learned, I would write that as 2x to the 4th in parentheses raised to the 5th power divided by 3 raised to the 5th power. Now I have to use some of the previous exponent rules that I learned. So the top, that 5 would apply to both the base of 2 and the base of x to the 4th. So this would become 2 to the 5th times x to the 4th to the 5th, all over 3 to the 5th. And now I have the rule from the first video where we have a base to a power raised to another power. I multiply those two exponents. And so this would become 2 to the 5th, which is 32, x to the 20th, because 4 times 5 is 20, and then 3 to the 5th, which if you're not sure what that is, you can pull up your calculator and put it in. 3 to the 5th power, we get 243. If you wanted to check the 2 to the 5th power, you could check that as well. So we have 32 x to the 20, all divided by 243. So as you can see, sometimes you have to use more than one exponent rule together in order to simplify an expression. The last one for this video is the zero exponent rule, which says that any non-zero base raised to the 0 power equals 1. So for example, if I had parentheses -3, close the parentheses and raise it to the 0 power, that will equal 1. If I had 5 to the 0 power, that would equal 1. If I had some complicated expression like 5x to the 7th over 2, and that whole thing in parentheses is raised to the 0 power, that's equal to 1. Where it gets a little more complicated is if you have a coefficient out front. So let's say I had -2 and then parentheses 5x, close the parentheses, raised to the 0 power. So here only the 5x is raised to the 0 power. The -2 is not. So it's -2 times 1, because the 5x to the 0 power is 1. So -2 times 1 would leave me with a -2. Only that part that's being raised to the 0 power, in this case the 5x, only that part is equal to 1.